Hi, this video is about a concept in physics called work. Now, the goal of physics is to make sense of the world as it naturally is. I think there are a lot of reasons why someone might want to learn physics. Maybe you'd like to figure out how some aspect of our world works so that you can make some kind of new technology and solve some kind of problem. Maybe if you're like me, you're just naturally curious about the world and you want to know how it works. Maybe you want to pass a class and graduate from high school or college. Whatever your reasoning might be, I think there is one reason that's more important than all of those. The most important reason why you should want to learn physics is because when you learn physics, you're really learning about yourself. You are a part of this natural world that we live in, for the time being at least. And when you learn physics, you're really learning about your relationship with this world. Equipped with just a few physics facts and a thoughtful mind, you can see yourself and the world around you in fuller color and clarity. Now, to learn physics, we use various tools or concepts to describe our observations of the world, and each tool has its limitations. So, one example of a tool we use in physics is a concept called forces. And I like to think of forces as kind of like a hammer. A hammer is, simple, effective, and it gets the job done most of the time, right? You can do a lot with a hammer. And forces is kind of like that in physics. There's another tool or concept in physics called momentum. And momentum is sort of like a screwdriver. It's more useful in certain situations. You can use it a little bit more effectively than a hammer, and you can get by it and use it for certain applications a lot better. But there's a third tool that's even more powerful than the other tool and the other two tools that I've mentioned. And this third tool is sort of like a power drill. You can do a lot with a power drill. It's very powerful, and you can do much more than these other tools. And a power drill has many different attachments that you can attach onto it that can allow you to do different things and serve different purposes. So I can attach different things to this tool, and it lets me, do certain kinds of applications. This video today is about just the first and most basic attachment to the power tool that we're going to be learning about, the most powerful tool in physics. This video is about the concept of work in physics. This idea of work is a very important and basic tool in the physics toolbox, but work is really kind of just like the attachment. We're not going to really see the power drill part when we're just studying the concept of work. It's like we're just looking at the small attachment. But once you understand the concept of work, you can start to appreciate the power of the most powerful concept in all of physics. So let's talk about work. What is work? Work is an action of sorts in physics. It's something that gets done. We often say that work is done on an object when a force acts on an object over some distance. So an equation that we use to describe this quantity, this measurement that we can make about an object, that the work done on an object is equal to the force applied to the object multiplied by the distance. So work is equal to force times distance. I'm using delta x here. Sometimes you can just write d, lowercase d, but delta x is the change in the position, so how much an object changes its position by. Work is a scalar quantity, which means that you can describe work fully by its magnitude alone, just by how much work is done. There's no direction involved with work. There's not a positive or negative direction. So let's look at some examples of work being done. Let's say I have this book, and I want to lift this book up. Okay, when I lift a book up, I'm doing work on it because I'm applying a force to the book and I'm causing that book to move a certain distance. While I hold the book out in front of me like this, I'm not actually doing any work on the book. It does take some effort on my end to actually hold the book up, But that's not what work is in physics. Work means that you are applying a force to an object, and that object is moving over a certain distance. What about if I drop the book? Is work being done on the book as it falls? The answer is yes. What kind of force is acting on the book as it falls down? The force is gravity, and there's a distance that the book is traveling, and so work is done by gravity on the book as it falls down. What about, as another example, let's say I have a baby. As I lift the baby up into my arms, I'm doing work on the baby to lift it up. It takes work to do that motion of holding up the baby and moving at a certain distance. Now, as I hold the baby, I'm not actually doing any work on the baby because the baby is not moving a distance. It's not moving some kind of distance across the room. I could actually walk with the baby across the room. And while I'm walking with the baby, I'm technically not doing work on it either, because work only happens when your force that you're applying is in the same direction that the baby is moving. So right now, I'm holding the baby up, applying a support force or a normal force to hold the baby up, but the baby's not moving up anymore. Instead, when I'm walking, the baby moves to the side, and that is not considered work being done on the baby. Another example would be just pushing against a wall. Okay, and when I push against the wall, I am exerting a force on the wall, but the wall doesn't move, and therefore work is not being done. And so, in conclusion, work is only done when these two conditions are met. This is the way that it's been defined in physics. Work is only done on an object when the object moves and the force acting on the object is directed parallel to the object's velocity. In other words, when you're applying a force to an object, that object has to be moving along with the force, either in the same direction that you're pushing, or the object is moving one direction and you're pushing against it or pulling against it. And so that's the only time work is done on an object, when your force is directed parallel to the object's velocity. That's all I've got for you in this video. Remember, habit is the battleground of character.